Welcome back everybody, and thanks for stopping by. In this video, we're going to be diving into our next topic, which is going to be VLAN level ACLs or VACLs. Now, in this particular design, what we're going to be doing, and we need to understand a little bit about our topology as well, is we're not in Eve at the moment. We're actually inside of some physical infrastructure, because during some testing it became pretty well and obviously known that Eve has some limitations as to what it supports. Specifically, it doesn't support VLAN ACLs, MAC access groups, or private VLANs apparently. From what I've tested out, those things just did not work. So in finding that out and doing the testing, I figured, okay, well, I can, I still have all the physical hardware. It's just a matter of, doing a little bit of manipulation in the back end. So the switches in the firewall are all physical switches. So the lab switch we have is actually connected right here. I'll go ahead and pull up the virtual machine that I'm connected into to do this. I will be configuring the lab switch from this particular console window here. So this is it. It's a show version. It is a 3750, just a flat 3750 running 12.4 code, 12.450 or 12.2 code. Sorry, 12.255 SE12. And the PC3, PC1, and PC2 are virtual machines running inside of ESXi. So if I go ahead and pull them up real quick, I'll go ahead and pull up. They are not currently powered on at the moment, but I will go ahead and power them on. And it shouldn't take long for them to come up. But basically what's going to end up happening is PC1, PC2, and PC3 are all going to be virtual machines that we're going to be able to mess around with. And what we're going to be doing, these are Windows 10 boxes, by the way. So there's PC1, there is... Go ahead and bring up PC2, and I have SRV1. I've added that too so that I could do some other manipulation. So I'm going to go ahead and open the console for him as well, and that'll be that guy. And then last but certainly not least, we'll do server 1. Now what this will allow me to do, and we'll talk about while this is booting, I'm actually going to go ahead and I'll go open console on that guy as well. Bring server 1 over. There we have it. So let's talk about what we're going to be doing first and foremost, and talk about what the ACL does and that type of stuff and why that's important. So first and foremost, where is my? There we are. So first and foremost, we have a situation where if all of these ports right here, this port here, this port here, and this port here are all inside of the same VLAN. Let's assume this is VLAN 10. Now what's going to end up happening is all these devices should be able to communicate with one another. Now communication is obviously a good thing depending on the situation at hand. But if you're all in the same subnet, or I'm sorry, all in the same VLAN, what does that mean long term? That means that one, you're going to be the same broadcast domain. Right, same broadcast domain. Now, being in the same broadcast domain isn't a bad thing. It's just something that you need to take into consideration when you're going about doing your day. Now, here's the thing. When you're in the same VLAN, you have basically all IP traffic is permitted. Okay, that's the design of the VLAN. But what if you want to limit that? Let's say, we'll say for instance that this guy right here is actually server 1. And server 1 has a HTTP enabled for the web server. PC1 and PC2 want to be able to communicate with that, right? But server 1 also has the telnet port enabled, which is obviously port 23. But you do not want to allow, let's see here. You do not want to allow that communication to go through. So these guys are not allowed to talk to each other. So if we go back to HTTP traffic is permitted, but telnet traffic is denied. Okay, so that's basically the logic we want to achieve. Normally in an ACL, or normally within a VLAN, you can't do that unless you do a VLAN level ACL. So let's go ahead and talk about exactly how we're going to do this, because I think it's definitely important for everybody to understand what it is that you're getting yourself into when you're doing this. So now that these devices are booting up, let's go ahead and pull up the original PC1. This is going to be our server, and if we do a show VLAN brief, we're going to have a number of ports inside of do show interface status as well. We'll look through here, and we're gonna have port 1, port 2, and port 3 are all up. And if we do let's do a quick breakdown as to what we're talking about here and what we're doing, because there's some physical wiring involved here, so we have to kind of figure out who's who. So if we pull up PC1 and we log into this guy, as you can see, we're running Windows 10. So we'll give that guy a minute. And the RAM on these guys is a little low. It's only 2 gigs of RAM to save on resources. But as soon as this guy logs in, we will, yep, that's fine. We'll open up the network and sharing settings. And then we will go to network and sharing. We'll go to Ethernet 0 and we'll click on details. So 4C47. So let's do a show MAC address table dynamic and hit the enter key. So right now we don't have any communication going on. So there's nothing's been actually sent. So if we were to go over here and type in Charlie Mike David or command prompt, and we were to go ahead and say, let's go ahead and pin that to the taskbar, and type in ipconfig, and type in ping 10.255.1.1, I can ping it, and if I hit the up arrow, I should have, I don't have a MAC address table. That's awesome. That's not cool.